my business Ada because I thought Ada was a very good language. So I'm not praising Ada because that's what my company is doing. And the other way around. I made a company of it because I thought it was a good thing. Okay? The other thing is that, of course, I won't turn you into Ada programmers in 45 minutes. That's too short. So I just give some examples, and I insist on syntax, no we care about that, but on spirit, and I try to show you what's different with Ada, what the spirit of Ada. There is plenty of documentation, including on the web, that can help you in learning the language. So you hear a number of dates connected with Ada. The first book, it was named after Ada Byron, who is supposed to have been the first programmer in history. She wrote programs for the Babbage machine, and well, she could never run them because the machine never worked. But her programs were later recorded in PL1 and worked right from the start. So the first program in history had no bugs, and the first programmer in history was a lady. Of course, we changed that since then. So the first version of the language appeared in 1983, so that was the original language, and it was quite advanced. It was mainly a synthesis of all the good ideas that were found in previous languages. For the first time that you had a language with exception, generics, and parsing together in the same language. You had those features in other languages. Having them all in a single language was new. A big step was in 1995, which added object-oriented programming, various synchronization mechanisms, better organization of big projects. Know that it was the first language standardized at ISO level. Oh. It was the first language, the first object-oriented language to achieve ISO standard 3 years before C++. There was a further improvement in 2.05, adding interfaces like you would find in Java or C#, and improving existing features, increasing the library. And now the latest issue in 2012, I have the standard here. I took it with me, but if you want to have a look, you're welcome to ask me. Brand new, just out of the press, I received it 2 days ago. And that made a big effort towards more formal, going more formal with programming by contract and things like that. You will have other talks during the day about that aspect. So move towards more and more provable and formality. Since we're at FOSDEM here, let me emphasize that it's a free language. What does it mean? First, it's an international standard. They don't include anyone. It has been designed by independent experts from various countries. And it's entirely controlled by you. Does not belong to anyone. And the effort around Ada was always very careful to have everything wide open. And you can see that this book has been published by Springer. I have here a picture that I where I picked it up from that very book. And that says, that's from the copyright, the first page. This document may be copied in whole or in part, in any form or by any means, as is or with alteration. Have you ever seen such a copyright notice on a book by Springer? The EDA community was very insistent to keep everything very open. You have free compilers, you also have proprietary compilers. We are in an open world and competition. Many free resources on the web, so here are some pointers. Maybe I should have changed those. You know, the big sites are moving depending whether the volunteers have time or not to pick the site. So there are maybe not no more than just one. And you have news groups, you have many rooms where you can find helpful people if you need any question, provided you are not a student who is trying to make his homework over the web. Otherwise, if you're really having a problem, people will be happy to help. Now, you may think that you've never heard of something written in EDA, just because generally you don't know. The TGV, for example, has many parts running on EDA. I don't have the picture, but the new automated line of subway in Paris, line 14 and now line 1, are entirely in EDA. There is lots of EDA about the A380, and that's a probe that landed at a satellite of some planets. It was a very successful too. And this is the Envisat satellite, the biggest satellite ever launched by Europe. So, what makes it different? We usually say that to use the open failure is not an option. You see that in everything we say, think, safety, checking. Checking is the important thing. Of course, when everything is working, you don't need to check anything. But it's time we get rid of the old myth of you write a program, then you debug it, and then it works. We know that's not the way things happen. The programs are evolving, there are constantly new contexts and so on. So making them safe requires always checking as much as possible. However, in a sense, data is very important for systems that are not life critical. Because life critical developments have lots of money to make sure that they operate correctly. If you don't have that lot of money, you better have tools that ensure that your program is correct. So in a sense, it's more important to have a strong language when you are not doing safety critical stuff. Thinking, well, I talked about that also this afternoon. But people are still mourning about buffer overflow. That problem has been solved 30 years ago. There is no buffer overflow data. Full stop, that's not possible. And arithmetic overflows and non-pointers are all detected. It's not a problem. And more, what's important is checking at compile time. When you start programming in EDA, the first thing you realize is that your program never compiles right out of the box. There is always something wrong, even if you're an experienced EDA programmer, believe me. Because the language is checking so much at compile time to save you time at runtime, of course. Having a bug detected at compile time, it's much faster than having to find it at runtime. So having checks, having safety needs a lot of rules that will forbid. So very often people tell you my language is very good because it allows many things. Other people would say our language is very good because it forbids. Because when things are forbidden, that's when you can check something. If your language allows anything, like C, C is made under the assumption that all checks are the responsibility of the programmer. And it's a very good language at that. But don't expect it to check anything for you. If everything's allowed, there is nothing. So, here is a small picture of ADA. On the basis is a very classical procedural language. It's not functional like Lisp or deductive like Smalltalk or something like that. It's a good old language with statements, variables, and things like that. It's based on Pascal. The requirements for the language stated that it had to be based, syntactically speaking, on some existing classical language. And all the proposals that made it to the semi-final during the selection process were based on Pascal. Because if you want readability, Pascal was the best basis to start from. Independently of the rest, C, readability is not the best aspect of C. Okay? And all the C language, many things are just, many errors are due to stupid syntax choices in the beginning. On top of that, you have a very strong typing system, really very strong. What I mean is that the typing system is the backbone of the language. Everything, every property is expressed in terms of types. So that's something you have to understand, and that's what is quite different, because other languages like even Pascal, Java, whatever, looks like wiki type when compared to Ada and Unity. So that forms the basis that supports everything. Then you have features that each support one aspect of software engineering. Packages support modularity. They are the basic modules. It's funny that many newer languages do not have the notion of module. They have classes. Sometimes you use classes as modules. But that's different. A class is quite often too small to gather all the aspects related to something in your program. A logical module is a bit bigger than what a class can achieve. So we call that typing. You have a bit of that notion with namespace. But namespaces are not as well packaged as the exceptions. Now it's more common in programming languages, allow you to deal with every unexpected thing that can happen. And for instance, Ada has been designed, among others, for embedded systems. And when you have a rocket flying and there is a problem, you won't run after it to press Ctrl-Alt-Del. The software has to care for everything by itself. And the principle is that everything that can go wrong in a program gives birth to an exception and that the program can handle. If you compare it to C++, for example, the philosophy in C++ is that the compiler should not introduce code that the programmer didn't write. Therefore, if you have an arithmetic overflow, well, what happens, you don't know. It depends on the compiler and the machine. Because the language is not allowed to raise an exception by itself. In Ada, everything is checked, and if something goes wrong, an arithmetic overflow, even if you call something written in some other language, you may have memory violation. And then it's coded by Ada as an exception in order for your program to be able to handle it. So that's runtime thing. Generics, like C++ templates. They're very useful because when you have strong typing, an algorithm that's written for a certain type may not work for other types. So it's a way of generalizing algorithms over a whole range of types that feature a certain number of properties. Tasking, multitasking, multi-threading, if you want, always part of the language. It's an integral part of the language. It's not libraries outside of the language. The language has been designed with multitasking in mind. And it's very important because the fine way some features behave can be different if you have multitasking. You have to be very careful about some features. By the way, one of the improvements of Ada 2012 is active support for multi-cores and things like that. So that's just fresh. We'll have some talks about that, I think, during the And the goal is to support programming methodology, the rules here. You know, some people say what's important is to have good design and programming methodology. Everybody will agree. Nobody will do it, but people will agree. And then they say, well, once you have a good design, we don't care about the coding language. To that, it answers no. Why would you stop the rigorous, the rigorous process when you come to the coding phase? We see the coding phase as going after the design, and if the coding expresses the notions of the design, then any fault, any defect in the design will translate in a program that doesn't compile. That's very nice. Quite often I see people in my office, well, we can't get that to compile a damn compiler. Wait a minute, you see what you're doing? You should do what you want. Stop thinking, and oh well, then maybe I made a design mistake at that point. And when they redesign it the right way, it compiles. Because you express the same notion, so if your design is inconsistent, the types will be inconsistent. Of course, it's no guarantee, but in practice it happens quite often. Including, of course, the object-oriented methodologies I mentioned, which was not well supported in 83, but in 95, very good. Plus, the little dot houses that are kind of extensions to the language that are still standardized for spatial domain like system programming, distributed application, business, and so on. So these are complementary libraries, but in a sense that are not part of the language. There is no syntax in those ends. All that makes something that looks very classical when you read it. A very common language, but in practice and in the way you use it, it's much more different than it seems. Especially, for example, speaking of object-oriented programming, you may be surprised that there is nothing called class in the language. The reason is that it's a building block approach. So that's the difference between a plain model and Lego. With plain model, you have nice little pieces that are all made for a special purpose and that you cannot use for anything else. My kids had the Playmobil at Snow with people with skis and so on, and the circus Playmobil. There is no single piece from one box that you can use to play with the other box. They are perfectly fit for one purpose, you cannot use for anything else. While with Lego, you have building blocks that have absolutely no interest by themselves. Depending on how you assemble them, you can get very simple things, or very sophisticated ones, or even different. So, that's why you won't find a class is, for example, we need to talk more about that, is a design pattern using the various pieces that are shown on the little thing. So that's the syntax looks a lot like Pascal, as I said, with some improvement. For example, in a for loop, the C here is local to the loop. It doesn't, it's created when you enter the loop, disappears when you exit the loop. So all the bugs created by reusing a not so sure value of a loop variable after you exited the loop is simply impossible because you don't have a test. And there are rules in the language that make sure that it's impossible to change that variable within the body of the loop. So, if you see for C in color, right, then you are guaranteed that C will go through all the values, and without inspecting the code inside, you know that nobody will cheat with that. So it is formal proof. It gives you more confidence in what you are doing. Here I have an if that you can write with else if. So you have a COM structure. And you have the case statement, like the switch statement if you want. But the very nice feature of the case statement is that when you don't have one other that covers all other values, of course, then the compiler will require all values that are possible given the type of I to be explicitly given. And that's the main reason why everybody recommends using the case statement as much as possible. Because if you change anything in your program and forget to make a change to some case statement, the compiler will say, oh, sorry, you missed a value here. Please tell me what I have to do. That's another very common case of bug that gets completely eliminated at compile time. It's very expressive. For example, here I have a matrix. I can give values of belonging to an array type directly. That's how we write, for example, a 2x2 unit matrix. Or 3 units, that's important. Being convenient to write is not important. Being able to convince oneself that what is written is correct is very important. Few times writing, but a lot of time reading and trying to understand. Also here, that's how you would make the start of a linked list. In the head, you put a new node initialized by 10,000 matrix value, and the next is a new node initialized by 209 and next node. You can describe the creation of a part of a linked list in one statement is not important, but directly you can read the global picture. That's what's important. You don't have to be drawn into all the details. And, oh yes, and it's especially important in the context of free software. Because free software means that your code will be read by thousands of people all over the world, millions in some cases. So readability is, I think, even more important for free software. So what do I mean by strong typing systems? Here I have to define an integer type. We don't use, except in some rare cases, predefined types like integer or non-integer or things like that. Because it has nothing to do with the problem domain. What you express in Ada are the types from your problem, not the types from the machine. So if you deal with an age of a person, you would define a type age as a range going, for example, for human beings, that's enough, 0 to 25. If I have the floors in a building with some parking in the underground and some floors off the ground, I can define floor as a range going from -5 to 50. Fine. 10 is a value that's acceptable for both types. That's why I can write that. However, if I write my age canonical, assignment is canonical, canonical my floor, the compiler would complain saying, no, my floor is of type floor, my age is of type age. It's not consistent. Well, tell that to a kid, he won't be surprised because they've been told for, even kids have been told for years, not to mix apples and oranges. But Ada is the only language where you cannot mix integer types, where they are typed in the physical sense. And that finds also a lot of errors at compile time. How many times do you confuse two parameters? You may have two parameters of different types. If you give them in the wrong order, the types will not match, and at first comparison you will have an error. But it's more important than that. It's a change of paradigm. Usually you write, you have machine level types, bytes, ints, and so on. Normally, in the design process, when you have a high-level type, like age, floor, and so on, you should investigate what the needs are for your type, and then do what is called a choice of representation. Which machine type will I use for that high-level type? You are doing the mapping between the high-level type that comes from the problem and the machine type that will be used for it. The big difference is that in Ada you express your requirements at problem level, and the compiler does the mapping to the underlying machine types, which has an immediate implication that you have no problem in moving from every machine to another one. If the underlying types are different, the compiler will do a different mapping, but since you expressed it at that level, you just have to recompile it. That's all, and the compiler will do what's necessary. So packages are a way to express modules. It's also a basic building block to put together things that are logically related. So, for example, here you would that's what we call an abstract data type. You can define what's called in other languages as an opaque type. A type you don't know what's inside. That color, we call that is private. Here, for example, fixed point type, also something that you rarely find in programming languages. So it says its value between 0 and 1 in a step of 1 over 2. I can define abstract values of that type. At that point, I still don't know what they are. And I can have things like a plus operation between columns, and I mix them, or a star operation changing the density of a column. But since the compiler has to know the exact representation, you have a private part that tells the truth. But the user cannot use that. The package is protected. It's impossible to make any use of that except in what we call the body of the package, where you will give the exact implementation for all the operations. So in a sense, we separate what we call the specification, the what the user of a package has to know to use it, from the how it's implemented, which is in part in the private part and in the body. It's a bit like having a .h and a .c. The main difference is that the .h is a convenience, but nothing prevents you from not using the .h and cheating by giving prototypes that do things completely different. In Ada it's all checked, therefore you have no way to go around the safety issue. And then, well, that's how we use it. So the goal is really to enforce abstraction, once again making the logical view separated from the implementation. Another thing that I mentioned now is that width that you have here. Every module that makes use of another module must name it in a width form. And this means that all dependencies between modules are explicitly written in the code. What this means is that you don't have any external tool, like a makefile, to tell what depends on what. In practice, the compiler will follow the graph of width clauses and see if something is out of date. It will tell you, oh, that is out of date, you must recompile. But of course, you have an option to recompile it automatically. And in most cases, Ada programmers never use the compiler directly. They just say, well, it's the command variable, say that make or something like that, and the name of the main program. You just compile everything that's needed without having a makefile. But it can be all needed from the source code. And frankly, how do you prove a makefile? Well, right? A nice feature that is rarely encountered in other languages are discriminants. Discriminants are a way to parameterize a data structure the same way as you would parameterize a subprogram. So for example, here I have a student record. Well, depending, first, people have different name lengths. So I can parameterize here with the length, the name of the people, and I can have a variable structure, a variant here, and if the major is letters, the people have a in Latin. If it's science, they are taking physics and chemistry, technology, drawing. And of course, all access to those called components is checked against the major. And if you are in sciences and you want to pick up the grade in Latin, that will raise an exception. Only the proper structure is treated, and that's important of the code. If the different variants don't have the same length, They don't take up the same space in memory. The compiler is able to allocate just the right space for the variable to be counted. So the other really don't exist. So the discriminants, in a sense, are to data what providers are to support. How are we doing object-oriented programming? Well, we think that packages basically support encapsulation. Type types are special types that support dynamic binding. So that's when the building block approach comes in. A class, in a sense, is encapsulation plus dynamic binding. So it's a design pattern with tag type in a package. Typically, you would have a package like widget with a type that carries on all the data of your object, and the method would be the operation procedure and function defined in the package that operate on the. And you can derive and extend the data either visibly or even privately, like here. You can redefine the method you have defined here, and then you can have dynamic binding. That's required for object-oriented programming. The nice thing is that object-oriented programming is in no way connected to pointers. In other languages, you always have pointers. Don't tell me that Java has no pointers. In Java, everything is a pointer, so you don't have to tell. That's slightly different. In Ada, you can have really no pointers in an object-oriented program. Because Ada, right from the start, has the ability to allocate things on the stack whose size is not known at compiler. That's the problem. That's why the other languages always use pointers. Because with object-oriented programming, you don't know the type, therefore you don't know the size of the object. So you need, when you need to allocate, the need to have a malloc. In Ada, we don't need that. Therefore, well, we often use pointer with the object-oriented programming because we need linked lists, trees, graphs, things like that. But with the pointer, because we have recursive structure. Not because of object-oriented. And there are many other features in Ada, that makes pointers much less necessary than in other languages. And that's really important. Another thing that's quite original in Ada is that you differentiate the specific type from a class-wide type. What does it mean? Here, I have a usual inheritance tree with widget windows that are different kinds of widgets, pop-up windows, and pop-up menus, and various inheritance. In Ada, Ada is strongly typed. It's already mentioned that. Therefore, if you declare a variable as a menu, it's a menu and it's nothing else. But sometimes you want to handle everything that's derived, that's belong to the class and the subclasses of the menu. And then that's what we call a class-wide type. Therefore, widget is only the widget itself. And widget class is the tree of everything that hangs below widget. So we differentiate between a node and the subtree that's defined by that node. So that, well, there are many things that can be said about that, but the main idea is that quite often it can enforce strong typing, even in a world where dynamic typing makes it difficult to enforce strong typing at compiler. So, for example, if I have a move procedure, that takes a rejected class parameter. It means that this procedure is applicable to anything in that tree. But still, you have only one move procedure that can be applied. It's not a method, that's what I want to say. The method is when something like ping, where each object in the tree has a different way, a different method for realizing the abstract fact. But here, a move is the same for everybody. Therefore, there is only one move procedure that works for everybody, and you are guaranteed that nobody will define move doing something weird in some corner case. Note that, well, since ADA 205, ADA allows you to use the usual notation object method. Some fields suggest syntactic sugar, some very wanted that very strongly, so I didn't do that here. Interfaces were added also to level 5. Well, that's not really new. It just means that the type may, like in Java, C#, may derive from one real type and as many interfaces as you want. So, for example, if you want to implement a persistence, then you would say that persistent with load, you widget that window, and persistent. So you can add as many interfaces as you want. They're just a kind of abstract classes with no data, and abstract or no support. A word of exception, as I mentioned, everything results in an exception in ADA, and every exception can be handled. So there is a good saying that says, once you've taken care of the unexpected, take care of the unexpected. Okay? Because everything results in exception, you can always take safety measures. An example of generic, well, if you want to swap two variables, clearly the same algorithm, irrespectively of the type of the variable. Therefore, you can make it a generic about, because I put generic here. And what's here is a generic contract. It says, give me a type, of course I don't have time to explain the syntax in detail, but what it means is that any type that has properties, the private type, is appropriate. And, well, that means that all you can have on such a type is assignment and comparison for equality or unequality. And then you create a new procedure, swap ages and swap age, which means you ask the compiler to write a new procedure here from that template, from that model, where you would replace everywhere item by page. So, in a sense, it's a bit like a macro, but actually it's quite different because it's a logical substitution. It's not a textual substitution. You don't substitute characters. You substitute a type by another. And a nice feature of ADA is that generics are compiled, and if the generic compiles and you provide a correct type for the instantiation, then the instantiation is correct. You don't need to recheck the body at instantiation. That's a huge difference between ADA's generics and C++ templates, for example, where the correctness is rechecked each time you make a new instantiation. Tasking is an integral part of the language. So, going faster, you will have other presentation about that in the afternoon, but I emphasize that it's very easy to use. People don't consider solutions to the problems within tasking unless they are really forced to, because in general, writing threads is very complicated. In Ada, it's just a data type like the other one, and it makes it very easy to have some little tasks doing some side stuff in your program. Since you are working at high level, you may wonder how you access the low level if you need to. Well, you still work at high level. The idea is that for a given type, you can give what is called a representation clause or representation aspect, nowadays, where you specify bit by bit how your structure is laid out. Then you still work at high level using the regular structure, and the generated code will be exactly what you want. That's an answer to people who say, well, I'm doing bit twiddling, therefore I need a low-level language. The solution in Ada is describe the high-level language, describe the low-level structure, therefore you can still work at high level and let the compiler do the hard stuff moving from the high level. Well, you can access memory. I see that moving, yes. Well, we have 5 minutes. You can handle interrupts in Ada. Well, everything can be done. But there is always something that forces you to make sure that it's quite feasible. You can slip things under the carpet. You have to announce with a whisk clause or something like that, that in some module you are doing some low level stuff. So as I mentioned here are the annexes for various needs. And well, what's interesting for free software? First, it's a really portable language. That the definition makes sure that it does not depend on a particular machine architecture. So don't tell me Java is portable, for example. Java is the least portable of all the languages. It works on only one machine, on the Java machine. The fact that you emulate that machine on various other machines is totally different. In terms of language definition, the Java language works on only one machine, and it's bound by the machine. But if you want, we have Ada compilers for the Java machine and even for the .NET machine. There is a validation tree that checks that all compilers implement exactly the same language. So this is checked by all compilers, and it's a guarantee that they compile all the same language. And those high-level contracts protection. I can tell you, I have developed several applications, and many people here that I know have developed applications that are 100% the same code between Linux, Windows, and other operating systems. GNAT is a free compiler. And one of the very nice things is that you have very good error message. That's a real help. For example, if you forget an S here, the compiler will tell you, oh, that's a possible misspelling of that other part. It's very clever. Or if you are used to other languages, you can say, oh no, in Ada you don't write it equal, you write it common. That's very good thing that saves you a lot of time. Be assured, in the first time, strong typing is a pain because you write things and it won't compile. Damn compiler. But in the end, you realize that it protects you from many mistakes. And when you understand that strong typing is a help, then you are really okay. As we said, if you compile it well, of course, you can have some logical errors. But when you compile, you are far closer to the achievement that you will make. You can interface with other languages. We have AWS, I'll talk about that by the end of the day, and many other useful tools that are available. I'm going to conclude now. You might think at that point that I will tell you, well, use data. No, that's not what I want to tell you. You are grown-up, responsible people. I don't have to tell you what you have to do. So I won't tell you that. What I want to tell you is just, please, try it. Give it a chance. The open source community is generally wide open. They like to try different things. So make your own judgment, and make your judgment on trying the language. If you don't like it, fine. Everybody's different. I think that's not a problem. But many people simply never heard about it and just don't know how it could be a different approach to programming. So try it. If you have problems, many people on the net will be willing to help you. And, well, report next year. Thank you.
How's the support for linear algebra and the community in general? How's the support expected support being system for linear algebra and statistics professional?
Well, there is nothing standard. But there are very good tools to interface with GCC. You have an option when you combine and see each file. We have an ADA specification that allows you to access that. So that makes interface most libraries very good.
So you can use external language. There's no like good linear algebra or something expected in ADA itself.
Everything that is all those libraries and skills are not really part of the language. There are too many of them. And sometimes, people ask often why don't you have a practical none of them is a standard. So you cannot standardize on something that's not a standard. And I think statistical mathematical library, all the basics about real numbers, complex numbers, easy defined. The final word, at lunchtime, all the ADA people will stay in the room. And so if you want to ask a question, you're welcome. That's a 1 hour break for thank you for your attention.